Ciao friends! In this video I'm going to show how to use the Sankey Chart visualization to display a list of events at different states for the customer of your company, but the same could be applied to products. You may wonder, wait a minute, this is a SQL BI channel. We are used to talk about DAX and data modeling, now we talk about visualization. Well, not really. We have a problem with the Sankey visualization. It's hard to use as a visual, even though it's very powerful, because 90% of the times you don't have the proper data model ready for that visual. So what we're going to do, we're going to see what is a starting point. In our case, we have an example where we have a company that has subscriptions. The company gets leads, contacts by using the website or by using phone calls, and starting from the first point of contact, we analyze the life of each content, then the life of each customer through the different states that this customer has. So we want to display a funnel of these events, but we want to use the Sankey chart visual because it offers a perspective that could be very, very powerful. But this spatial visualization requires a proper data model. So we're going to see first, what is the data model we need to use? And second, how do we move from an initial model that could be very different to the proper data model, also looking at the different transformation in DAX, and as a separate example, we also have Power Query. We will not see in the video, but you have also an example in Power Query, because the initial step for a static visualization, you don't need to write DAX code. You can obtain the same result by creating a data model that has the data the right way. But the second step is that if we want to create a dynamic visualization by adding and removing events from the Sankey chart, at that point we have an additional issue. We cannot just create a static table that has all the solution. We have to do something more dynamic way. Yes, we have to use a DAX measure to do that. We'll see everything just in a minute. Let's start with the demo. We start looking at the result we want to obtain. This is the easiest way to understand what we are talking about. In this report, we see this visualization, this custom visual. You have to download the custom visual from Microsoft App Source, and this is called Sankey Chart. As you see, the Sankey Chart displays the relationship between different states. For example, a customer could be in a state, a product could be in a state, and this diagram is usually used to display the transition between one state to another. In this case, we are using this visualization to display how a customer moves from, let's say, one state to another. Imagine a company that sells subscription, and there are different ways to contact the customer. The customer could be contacted initially through the web or through a phone call. By using one of these techniques, we might have a trial, we might have a subscription. The subscription could happen immediately after the initial contact or after the trial. There could be a renewal of the subscription, there could be a cancellation of the subscription. There could be multiple events of multiple renewal of the subscription. We consider only the presence of at least one of these events, and these events are let's say sequential. So we make the assumption that every event can happen only after some other event. We could have missing events in the middle, but that's the idea. These are the assumptions we are making. In a moment, you will understand why we have to make these assumptions, because otherwise, without any assumption, it could be too complex to prepare the data the right way. So the idea is that we can clearly see that based on the web contact, we have a certain number of customers that went to starting the trial. A few customers went directly from the web contact to the subscription, which is this list of 2 customers, and so on. As you see, this is a static visualization. We also want to display a dynamic visualization that will change the requirement. For example, at the beginning, this is the same visualization we have seen before, but if I ignore the renewal, for example, you see that we reshape the visual, ignoring the presence of that event, which means that now the passage from subscription to cancel ignores whether a renewal was in the middle or not. So it's like we had the entire dataset without that event. This visualization could be particularly powerful to understand what is going on, especially when you have a large amount of data. But what is the data that we have at the beginning and how we have to structure the data in order to display this visualization? So first, let's start to see which data do we have. So at the beginning, we have just a list of, let's say, customers, or we say contact, because if we have a contact, someone who goes on the website and start a trial, if it is not a subscriber, it is not a customer. So we call them contacts to make it more generic. And we identify these contacts through an email. So let's say this ID could be a number, could be a string. In this case, it's just the email. And the information we have is just the date of each event. So this is very typical. We have a table with a list of dates, and each date represents when a particular event started. So the idea is that we say, once the contact establishes a first contact with the company through the web or through a phone call here, we say, okay, from that moment, the customer is, or the contact is in a web contact state. The moment the same person starts a trial, it becomes in a different state. It goes in a different state, and so on. So as you see, there are cases where, let's take a look at this. After the initial contact, nothing happens, which means that there was just an initial contact and no follow-up, no anything. We also want to be able to count how many of contacts we have in that state, because of course that could be the largest number, and so we want to be able to compare the ratio between the two. But we want to display this in a visual way. So let's say this is our initial set of data. The data could be organized in a different way, I know, but let's start for a moment assuming that this is the initial data. Let's take a look at how we have to use the visualization. So the visualization is a custom visual. As you see, we imported this custom visual from AppSource, and the visual itself has just 3 properties that we can see here. We have to specify a source, a destination, and the weight. The weight is how strong the relationship between these two states is, which in our case is how many contacts went from one state to another. Which means that, now if we understand what is going on, let's go back to the table. From this web contact state, so let's ignore date. Let's say that all the contacts that started the conversation through the web are in a state web content, initial state web content. Of those contacts, this is the number that went into a state start trial. And we also make the assumption that these states, these events, must be in order. So we cannot have the start trial before the web content, no matter which date is. So we are not looking into the date to see if it is greater than or equal to or less than. We just say if there is a trial, it should have happened after an initial contact. This is the assumption we are making. Again, to make it simple, because otherwise it's very complex. Now, knowing that, what happens? Well, we want to see we want to see web contact, which is what we have here, web contact, and we want to see start trial. So how many of those contacts went from one state to another? You see, this is the set of contacts that went from one state to another, and we actually have 9 contacts. We are using the Sankey visual, the Sankey chart, to display the funnel of the contacts we have that introduce initial content, initial leads, they become customer, and hopefully they will stay customer, but there will be a churn rate of customer that leave. And so this visualization display a more complex situation that could have multiple events. Now, we need a model where there is a from column and a to column, where the from and the to are the two columns that we apply to source and destination. And we need a measure that count how many contacts are in that state. The easiest way to obtain the table that can actually satisfy all these conditions is to create the table that I'm going to show you now, which is the funnel Sankey table. So let's ignore for a moment how we created the table. This is exactly the topic of the explanation, but this is what we want. We want to transform our initial set of data into this table. This table says from to and explain one row for each contact who transition from one state to another. This is exactly what we want, what we need. And by the way, by using this visualization, by using this model, we have the ability to include the contact ID, for example, in a list down here. And when we select an element, we can see who are those contacts that transition from one state to another. So it's actually a way to navigate and inspect the data, and if you want to take some action, this is an easy way to find who you are interested to. This is just an additional reason why we have one row for each contact. You could also use this table connected to other tables through relationships to propagate the relationship and do something else. We don't want to enter into that, but now the problem is, how do we obtain this table? Because remember, our initial table is very different. It's something like that. So it's just a table that has one row for each contact. We want to translate this table into one row for each event. Well, no, one row for each combination of events. This requires a number of steps. And in order to transition from this table to the table that we have seen here, so this is the static table for the first solution, the easiest way is to go through an intermediate step that we will see is also very useful to create the dynamic version, which is a table that has the list of the events. Let me explain. Let's consider just one of these contacts. So, and let's sort this in an ascending way. This table says this contact had two events, which means that in the initial table that we have seen before, this contact had only the first and the third date as events. So the event number 1 and number 3. If we go back to the contacts table, I think is this one, Christie 12, is the customer that has exactly two events, the web contact event and the start trial event. Now let's take a look at this list of events. So we have a contact that had everything: trial, a subscription, a renewal, and cancel. So let's see the name. Marco 14. So let's look for this contact name in the events table. So let's clear the selection and look for Marco. And here we go. Now you see we have this list of events. So this is the table we want to obtain in order to move from the initial table to the final table. Because once we have this table, if you think for a moment, the number 1 represented the starting point, and the following row represent the destination. 1 to 3, then 3 to 4, then 4 to 5, and 5 to 6. Which means that if you imagine to create another column here, you simply have to conceptually put in every row the next ID. And why are we looking at numbers instead of names? At the end, we want to see the names, but the numbers make it easy to establish the sort order we want to use to get the next one. So in other words, if I can create this table, now we see by isolating one content, we can better explain what is going on. But once we have a table like that, we have an easier way to create the following event, because we just have to look at the next one, the next row in the same contact. And And then, starting from this, we can create the other table. But let's go one step at a time. So assuming that this is the first step we want to obtain, what we have to do. So we can, at this point, comment the calculated table we used. In the file that you can, in the files that you can download, there is one file with the solution created by using DAX. But if you think for a moment, for the static solution, where we need to create the table that has from, to, and content name, we have another option, which is using Power Query, which is using SQL if you prefer. So the final goal is to obtain these two tables in order to enable both the static and the dynamic solution. And the biggest focus of this video is about the data model, not just the transformation. But we see an example by using DAX here. And this could be important because part of the DAX code we will see later is also necessary for the solution based on a measure. Because if you want to create a dynamic solution with a slicer selecting the events, then we cannot solve the problem by just preparing the data. We also have to apply some transformation at query time by using the information from the slicer and from the model to display the right data. So how did we implement this in DAX? In reality, it's relatively simple. You see that we have a union that for each type of event create a table, and then we concatenate the list of events. This calculate table basically does the following. It retrieves for each contact ID that has a web contact column that is not blank, it retrieves the corresponding row, and it includes in the second column the corresponding number. To make the code easier to read, we didn't write just 1, 2, or 3. We just used the web contact, and we retrieved this name from a table, event types, which has this content. So again, this table could be created in Power Query. We have a version now created by using DAX, but you could have imported this table for an Excel file, for example, is the same. So the event types table has the list of the events we want to display in the Sankey chart, and the event type ID also defines the sort order we want to display. You can notice that we have a special event at the end, 91 none, which is an event we need to include for a technical reason. The Sankey chart visual is not able to display an event that is made by a single date. Imagine you have a contact who established a first contact through the web and nothing happened. We want to see that there was an initial web contact without anything after that. It is not possible to display just the number in the visual here if this is the first event. You see that this can happen. For example, for the subscription, we see that this area represents how many people made the subscription and then didn't do anything. They don't have any event after that. But this is possible only if there was some event before. So we have a challenge, and this is, I think, a limitation of the Sankey chart we have today. It is not possible to create a data model where, for example, by specifying 2 as a blank, we would like to see that there is nothing happen after that. So what we had to do, we created this non-event to connect all the initial states that are also the only state for a particular content. This was a necessary step. So this is the reason why we have an additional event that doesn't correspond to any action, any event in the contact. So what we did is, okay, so we create for every date we have in the contacts table a corresponding list of contacts that have that date that is not blank. And the reason why we see this filter, all the blank row, not is blank, instead of a simple not is blank, is because we need to create relationships later, and we have to avoid any dependency on the blank row on the one side of the relationship. More on this later when we will see the data model. Now, we do this for every event. So this code is very simple. It's always the same code, repeated, repeated, repeated. And at the at the end, we also create another table in a variable with all those contacts that have only one event, because as we said, we have to add this none, and the assumption we have is that every contact has an initial event that is either web or phone. So our non-event could be connected only to phone contact or web contact because of the assumptions we made. Of course, you could use a similar concept for other scenarios where the entry point could be also a different one. But we have this strong assumption we have for this model. We know that this should be the initial contact for our the initial event for our context. So what do we do with the single events table? This is just the list of the contacts that have only one event. Then we combine the events that we have with event type ID, contact ID, just the number corresponding to the event and the contact ID, and we add to those the list of the contacts that we know have only either web contact or phone contact, no event after that, and so we add this non-event to make sure we also have those ones. And so this explains our table here. If I remove the filter, you can see that we have basically, we have to click all, sorry. By clicking all, I can see all the events. Now it is sorted by event type ID, and we see at the end these contacts that probably have only either one or two as an initial contact ID. Now that we have this table, the challenge is that, okay, basically what we can do for each row that is not the last one for a particular contact, we have to create the corresponding to. So this becomes the from event. We need to create the to event. So that's what we do in the funnel Sankey calculated table. And the funnel Sankey calculated table basically does the following. For each row in the events table we created, we create this to ID column, which we obtain by using the next row in the same partition of event sorted by event type ID. By using the window function, in this case offset, we say we want to get in the subset of the rows from the events table that have the same contact ID of the current row, give me the next one, so offset one go to the next row, matching the event type ID and the contact ID, sorting by event type ID. Basically, this is a way to say, give me the next event type ID for the same contact, if there is one. Otherwise, we get blank. And generate basically repeats this process for each row of the events table. So for each event ID and contact ID we have in the events table. At this point, the result of generate has three columns: the contact ID and the number that represent the from and the to. Now we have to convert these numbers into strings. And this is exactly what we do in from and to. So we use select columns to say we want to we want to generate as in the output a table that has one column contact ID, one column from, one column to, and from and to. Just use a lookup value that translate the event type ID into the event type using the event types table that we have seen before. And so this way we obtain this result. Now we have our from, our to, and the contact ID. We just have to create a simple measure, just count rows of the rows in the funnel Sankey, and this is enough to obtain this result. Remember, we could have obtained the same result by creating this table with three columns with any other technique. We have a separate file where we used Power Query to do exactly the same. However, if we use this technique that only needs a simple measure with just account rows, we have one limitation. The result is static. We cannot say, well, now I want to remove subscription and see what happens. Or more important, we might want to ignore the web contact. So we want to ignore the contacts that started their relationship with the company by using the web contact. We want to only analyze those that have had a phone contact as an initial step. And this is possible in the dynamic version. For example, here, if I say I want to analyze only the events following the web contact or following the phone contact, I can navigate this way, and I can actually make this dynamic, and this way I'm ignoring the web contact. At the same time, if I ignore both web contact and phone contact, it means that, yes, I want to start from start trial, but now I'm not excluding any initial state. So we had to write code to handle this specific assumption we made. But the point is that we are not able to obtain this result. In particular, we are not able to obtain the result of excluding all the following transitions for the contacts that didn't have phone, that had only the web contact as an initial step from the following analysis. And this is particularly important when you consider the use of the Sankey chart as a way to analyze the funnel from a marketing standpoint of the events that the company had. So to create this dynamic visualization, we need DAX code that dynamically filter the data according to our selection and rebuild the connection between from and to in order to display what we expect based on our selection of the slicer. So the solution to this problem is that instead of creating, so let's see this from a conceptual point of view, instead of creating the funnel Sankey table in a static way, we basically want to create this in a dynamic way. But in a dynamic way means that actually we cannot create the table and display the table as it was a table. This is not possible in Power BI. What we have to do, we have to create a model, a data model, so that we have 3 columns. We have actually 2 columns, from, to, and a measure to use to display the number of customers that moves from state from to state 2 based on the selection we made in the slicer. So this is more challenging. Let's see what we had to do. First of all, by looking at the visual we have. You see that this time the visual has a connection with 2 tables, Sankey from and Sankey to. If you think for a moment, we need to be able to show any combination between the 2 lists of events. And just using the table events, remember, the table events, event types, is the list of the events. If we need to create this in a dynamic way, we need 2 different tables, independent table that can represent the list of events for from and the list of events for to in the 2 attributes of the Sankey chart. And they cannot be this table because we want to use this table for the slicer. So actually we have 3 copies of the same table. This is the initial table, event types. What we did, we created 2 copies of the event types table and we named them Sankey from, Sankey to. Then we created a measure, funnel count, which count how many customers, how many contacts we have between the selected from and to based on the content of the funnel Sankey table. The funnel Sankey table, remember, I made a mistake. Not the funnel, so the funnel count is just the count rows, reset. The measure we want to use is another measure that we called Sankey, just Sankey. You see this measure that we created in the table event types, but actually this table internally is going to look at the events table. So by using the content of this table that we used as an intermediate step to move from the initial contacts table to the Sankey chart table, funnel Sankey table, we want to use this table to dynamically generate the combination of, or better, the list of contacts that satisfy the condition. Let's see how to do that, and of course, this is a more complex structure to use. Let's start taking a look at the data model, because as I said, this means that now we have two copies of the same table. So the table events, which is this table, sorry, the table event types, not events. The table event types is the table we want to use in the slicer. The table Sankey from and Sankey to, even though they are related with a one-to-many relationship, because if we ignore one event in the slicer, we want to ignore those events in the from and the to properties of the Sankey chart, in reality it would be a one-to-one. So we had to enforce the relationship as a one-to-many, because by default, when you create this relationship, you will see that the initial cardinality proposed is one-to-one, because the content of the two tables is the same. So we have to enforce this as a one-to-many. Just for a curiosity, you see that the Sankey from is just a copy of event types with just different names for the column. So this is what we have in the table. It's just a copy of the event types. But it's important to realize how this is applied to the data model. And the relationship is important because it automatically propagates the filter from the slicer. The slicer that also filters the events table that has, let's take a look, the list of rows, one for each event, for each content, each date. So when you filter with the slicer this table, if you ignore one event, that event is not supposed to be visible in the table when you read this table by using DAX by default. So the filter automatically propagates. And by the way, the filter also propagates from the contacts. So let's just go back here. What does it mean? Now we are not using properties of the contact, but imagine you have in the contact country, city, other information about the customer. Well, you will be able to also filter those customers, and you will filter the events table as well. So now, by using the events table, the rows visible in the events table, our measure must do the following. Based on the selection in from and in to, how many unique contact IDs are in that table, in the sequence that we expect. So we can finally see the definition of the Sankey measure. It's a long measure, and by the way, this is the simplest code that we can write, because as you will see, there is a different implementation that is twice faster but way more complex to write. So let's start with this one, because this is the one that we can try to quickly review. So we have a few variables that help us in splitting the processing in several steps. We assign the 99 special event to non-event. So this way, if we have to adapt this code to another model, we just have to change this line to reference this additional special event to connect the single events for one contact. Then we have these three variables that basically have the only scope to identify the condition where, let me go back to the report. If I select all the events, I want to see all the contacts. If I select web contact but not phone contact, it means that for the entire visualization, I want to consider only those contacts that enter the system with a web contact, and I want to exclude phone contact for the entire life. But if I unselect web contact and phone contact, this means that I want to see in the report only the events from the start trial. But actually, if I would exclude the contacts that had no web, no phone, sorry, I would exclude the contacts that had a phone call or a web contact as a beginning contact, I will not see anyone, because we said that every contact has either a web or a phone contact at the beginning. So the only possible meaningful use of this selection is that I don't want to see these events, but I want to see all the contacts. So I'm not excluding any contact, but I want to see the contacts that I want to display what happened from the start trial onwards, but I just don't want to display what happened before. But I'm not excluding any content this way. So in order to understand whether we are in this condition or not, we had to create this specific condition to understand whether the intention of the user, based on the selection of the slicer, is to show all the events or not. Now, at this point, we have to implement this filter. And the easiest way to implement this filter is to apply the filter to the contacts table. What does it mean? Technically, it will be possible to dynamically look for the first event for each customer and then filter the customer and then propagate the filter of the customer to all the following analysis. But this will be very expensive. We know that the first event of a customer is not going to change based on the selection of the user. It is either web or phone. So we can just assign this information to each contact by using, for example, a calculated column. In this particular case, the calculated column is a smart way to obtain the information in an easy way, because actually with a single line of code, calculate mean events event type ID, what we're doing is the following. This is easier to understand here. This is the calculated column. This calculated column says, for each row in the contacts, consider the list of the events for that content, calculate context transition, propagates the filter to events, and get the minimum value of the event type ID, the number that is used to sort the events by the sort order that we want to apply. So web contact, phone contact are at the beginning. And so we have either 1 or 2 for each contact. Indeed, if we display the contacts here, you see that this first event type ID is either 1 or 2 for each contact we have in the table. Now, think about this. If I know whether I want to show only 1, only 2, or both, I apply the filter over the column first event type ID of the contacts table, which is exactly what we do. Let's go back to the Sankey measure. This is exactly what we do in this step, first contact event types. So the filter we obtain is basically a filter that says, this is the list of the events we want to filter for over the contacts. And we use this first contact event types as a filter for the events table. So basically the first contact event types is a list of values in this column, first event type ID. So the table itself, the filter itself, is very small. It's just 1 or 2 rows. But because by filtering this column in the contacts table, we propagate the filter to the events table, this filter is a very effective way to isolate the events only for the contacts we want to see based on selection of the slicer. Then we have to exclude the non-event that we created mainly for the static visualization. In this case, the non-event could happen because of the dynamic visualization. It could happen also for the start trial. We said we want to see, and we want to see the events that didn't have any follow-up, but when you restrict the events visible in the Sankey chart, we have to consider this this possibility can happen at any event, not only to the first web and phone, because it's a limitation of the Sankey chart to not be able to display an event if we don't have a from and to. So the idea is that when we have in the list of the events selected only one event for one content, we have to add the non-event to the single event for the selection of the events that we made for the contents that we want to display. For this reason, though, we remove this non-event from the list of the events we want to consider, and then we use the selection that we applied in the from, we apply this filter to the events event type ID. What does it mean? Conceptually, this is what is happening. When you select from, you provide a list of the from events, and you can see this better in this table. This is the same content of the Sankey chart in a table. So you see that we have from event to event. So conceptually, we are generating all the possible combination, but the measure should provide a number only for the existing combination. So, for example, if we have renewal, in the filter content we have only this from event, so usually we have only one event selected. And if I go back to the measure, this means that my selection, which is usually only one value, is applied as a filter to the event's event type ID. Think about that. We said that this is the model we have. So we have from, we have to. Based on the data model, the selection made on from and to does not propagate the filter to other tables. But we consider, what do you select in from event? Nice. I get the corresponding event type ID and I filter events this way. So now we are filtering the events from. Of course, we have to retrieve the to event. So what do we do in the measure to do that? And at this point, we have, so this is what we obtain events from. Then we have this all selected event. I will go here in a moment. For each event in the events table, we created the to, the corresponding to event. But remember, we are, for example, getting only the renewal, so the only possible following event could be cancel. And in order to retrieve that, we use the very same technique we used in the calculate table. This is the reason why I wanted to show the calculate table at the beginning, because basically what we're doing is similar to what we did in the calculated table at the beginning, but now we're doing this in a temporary table computed in a variable into the measure limited to the scope of the event that has been selected. But the principle is the same. We look for the next event for the same contact. How do we look at the next event? Here is where all selected event is needed. We need the list of all the events that are included in the list of the events in the slicer. So in other words, if you are considering this example, remove, renewal, and cancel, we want to see how many customers went from subscription to, not to none, sorry, to cancel. We want to see how many subscriptions went from, how many contacts went from subscription to cancel, ignoring whether there was a renewal in the middle. And we see that 5 subscriptions have been canceled. We don't know, and we want to ignore whether they were renewed or not. We just want to isolate this event. And other 5 subscriptions are still active because they didn't, they weren't moved into a cancelled state. And in this case, they go to none because probably they didn't have a start trial as an initial event. So as I said, we might need this non-event because otherwise we might not be able to display everything. Of course, if we include web content and fun content, this doesn't happen because none is only needed for web content and fun content, and you see that subscription now displays this way the missing state. Again, this is a limitation of the Sankey chart. We would have liked to have a better visualization also for the first events, and unfortunately it was not possible. Now, this explains what we did at this point. We just have to explain the last step, which is what happens if we don't find the next event? Well, the next event could be a blank. How do we know whether we should so if we don't find a next event, we might have to show none, but we have to show none as the following event if and only if the event that we displayed was the first one in the current visualization for that content. And this is where our rank comes to the rescue. Because by using rank the same way we use offset, you see the parameters are pretty much the same. We check whether is the event for which we are looking for the next one the first one in the list of the events for that content. If yes, then we want to show non-event. And so Koalis says, give me the next event. You found blank. So if the event we're considering is the first one for this content, then show non-event, otherwise blank, because in that case there was a former previous event, and so it's fine, the visualization will work well. Now that we created this table that has all the contacts that are visible in the filter context according to the filter defined, blah, 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 we still have to make sure that the two events correspond to the selection, because if you remember, we used the selection in Sankey from to limit the list of the events to consider, but now we have to use also the selection made on to limit the list of events we want to consider. So this filter ignores those events that ends in a different to event. And so finally, the result is the number of events that satisfy the condition from and to, and all the other slices we have seen so far. So this is what makes this working. And so as you see, I can dynamically select everything, and the performance is relatively good because we have a small set of data. Now, you can see that the data set we used is just a small sample of data created in DAX. You can change it if you want. The funny thing is that if you want to simulate what happens with a larger number of rows, you just increase this multiplier. For example, if I put 100, now I'm multiplying by 100 the number of contacts I have. And so if I look at the numbers here, now you see that instead of 5, I have 500. And this is a good proxy for the performance analysis. I can tell you that if I go over, let's say, 10,000, 20,000 and more, I will start to see that when I click on a different selection, the performance will not be so immediate. I will have to weigh something more. At that point, you might discover that this implementation, which is completely different and in a way longer and more complex to read, is also twice faster, which doesn't change much, I will say, because if you have an order of magnitude problem, this is not going to solve it. But if you have something that runs in 2 seconds, it could run in 1 second. If you have something that runs in 20 seconds, you still have to run in 10 seconds. So it's probably not enough. For very large numbers, this approach is still expensive, the dynamic approach. The static approach will be very, very fast. The dynamic one, a little bit slower. And remember, in the demo files, you have this entire implementation and also the implementation of the static table in Power Query, of course, with the dynamic part in DAX, because there is no other way than using DAX for the dynamic visualization. So we have seen a lot of DAX code. We also have a lot of Power Query M code to do the same transformation. But if you want to achieve a dynamic visualization with the Sankey chart in order to display a list of events and the transition between states for customers, products, or whatever else you have, I think that this example provided you a good foundation to start creating the proper data model, the proper data, the proper structure to get a simple static visualization or a dynamic one, which requires a little bit of DAX, but you have at least 2 examples to start with for your model. As usual, enjoy DAX.